Hello, this is 1 hour complete basic electronics course. In this video we are going to discuss basics of electronics, about the basic component of the electronics, that how these components work and how to use these components on circuit boards. What is the function of each electronics component in a circuit? So in this video we are first discussing about resistor. That what is resistor, what is the uses of the resistor, and what types of the resistor we are using in the circuits. There are different types of the resistor. Each resistor we are using in their own function, means each resistor has their own functions. After the resistor we are discussing about the diode. What is the diode? What is the function of diode? Why we are using the diode in our electronic circuits? What is the main function of the diode? How many types are there in the diode? And how to check the diode in a circuit board? After the diode we are discussing about capacitor. What is the capacitor and how many types of capacitor are there? And how to check the capacitor? And what is the function of the capacitor? After the capacitor we are discussing about the transistor. What is transistor? How many types of transistor are there? And why we are using the transistor in our electronic circuits? After the transistor we are discussing about inductor. What is inductor? Why we are using inductor in our circuit? And how to check the inductor? And how many types of inductor are there? After that we are discussing about the schematic diagram, that how to read the schematic diagram of the circuit, and how to make a schematic diagram, and how to represent, how to read the symbol of each component in a circuit diagram. And what is IC? How IC work? What is the function of IC, and how to check the IC? After that we are discussing about the checking of the circuit board by the help of multimeter. How to check the circuit board, how to find the damaged component in our circuit board through the multimeter. So let's get started. What is resistor? What is the usage of the resistor? Why we are using this resistor in a circuit? A resistor is a basic electronics component for electronics which can resist the flow of currents, means which can try to decrease the flow of current. So here I will give you a simple example of water. For example, the water is flowing through a pipe. You need to control the flow of this water. So then you are using a valve. Through this valve you are able to control the flow of water. So there's also other method. When the garbage come in the root of water or between the water, so this garbage will try to stop the flow of water. Like this, an electronics wire, when the current is flowing, so the resistor is trying to slow the flow of current, is trying to decrease the flow of current. So this is also a resistor. This is a variable resistor. On this resistor we are able to increase and decrease the flow of current, while this resistor is fixed, working like a garbage, while this resistor is work like a null or valve, on which we are able to increase and decrease the flow of water. So it was the function of the resistor. There is different size in a resistor and different values in resistor. The different size of the resistor is due to the power or the wattage. Higher in size is having a high power to resist, to control the flow of current, while the small resistor has low quality to control the flow of current. Small resistor we are using in small circuits, while the large resistor we are using in a large power circuit. So this was the definitions and the working of the resistor. There are types of resistor and different value of the resistor. In this video, I will tell you that how to find the value of the resistor. There are different ways to find the value of the resistor. The first way to find the value of the resistor is a color code of the resistor. With the help of the color codes, we are able to find the value of the resistor. There are different color codes which indicates a different value of the resistor. And in some case, the value of the resistor is written on it. That resistor is called wire wound resistor. Third method is to find the value of the resistor is by the help of multimeter. We are able to find the value of the resistor by the help of multimeter or ohm meter. But in this video, I will tell you to find out the value by the help of color code. So friends, see here. There are different colored bands on the resistor, on the top of the resistor. Each color indicates its own value. So there are different types of a resistor according to the bands. You can see here, friend, there's also 4-band resistor, 5-band color, 5 color bands resistor, 6 color bands resistor. The rating method of all resistor is same. So see here, first you understand here. Each color has its own value. Here you can see the black color value is 0, the brown color value is 1, red color value is 2, orange color value is 3, yellow 4, green 5, blue 6, violet 7, gray 8, white 9. And gold has 0.1, silver has 0.01. So friends, see here. The first color is 2. The first color is red. The value of red is 2. So we need to write 2. The second color is blue. So we need to write 6. The blue value is 6. The third color is black. So the value of black color is 0. So we need to write 0. Friend, here you can see the second last color is always a multiplier. Means how? You can see here. The third color is orange. Here, the orange value is 3. So we need to multiply this by 3. So I will put 30. The value is 3. So it's mean we need to put 30. If the color was yellow, so the value of the yellow color is 4. So then we need to put 40. The second last number, the second last color, how much number is came? You need to put that much 0. At the last, the color is quite different. At last, you can see here, it's uncountable. The color is violet. The violet value is 0.1%. It means the error chances is 0.1. So friends, see here, the value of this resistor is 2,16,000 ohm. If we can convert this resistor into kilo ohm, so we need to remove the last 30 and replace by K. So it's mean the value of this resistor is 260 kilo ohm. So friend, like this, you are also able to find the other resistor value. I request to all, please you can try different value of the resistor to find the value. You can see here the 4-band resistor, how to read the value of the 4-band resistor. The first band, you can see here, the first band value is 2 because here the color is red. So you can write 2. The second color is purple. The value of the purple is 7. You need to write 7. The third color is orange. So the orange value is 3. You need to put 30 or K. Because the second last number I told you before, you need to put that much 0. So the value of the orange is 3. So you need to put 30. At the last color is uncountable. It's telling us about the error chances. So here's this color is, this is the green. So here you can see the value of the green is 5. It means this resistor has 5% up and down. So friends, see here how to read 5-band resistor. It's also like that, but the second last number you need to multiply that much number. The first value is brown, you need to put 1. The second color is green, you need to put 5. The third color is black, you need to put 0 because the value of the black is 0. The second last number color is red, you need to put 2. If we can convert, we need to put 2 0 because the second last number is multiplier. You need to put that much 0. So at the last there's 3 0. We need to convert into K. So friend, also you are able to find the value of the 6-band resistor. So friend, you are also able to find the value of their color code by the help of mobile phone. You can simply go to Play Store and download the color codes resistor apps and just put the color. Automatically it will tell you the value. So friend, how to find the value of the resistor? So this is the resistor or voltage dependent resistor. Here you can see at the top, the first 2 numbers indicate the diameter or the size of the resistor. So here is the 14. It means the diameter is 14 millimeter. The third number show the shape of the resistor. Here's D. D means disc shape. So you can see here it's a like disc. If instead of D there was S, so the shape will be the square, like a square. The 4th, 6th and 7th number will indicate the voltage. The voltage of this resistor is 241 volts, while the last K indicates tolerance. So here is K. The tolerance of K value is 10. It's mean the value of this resistor will coming 10% up and down. It's not a matter. If instead of K there will L, so it's been 15% will the chances of error. How much types of resistor are there? And what is the functions of each types of resistor? There's mainly 2 types of resistor: fixed resistor and variable resistor. The fixed resistor is that resistor when you put this resistor on the circuit board, then you are not able to change the value of this resistor. Therefore, it is called fixed resistor. While the variable resistor, when you can put this resistor on the circuit board, you are able to change the value of the resistance in the circuit board. While the fixed resistor is a fixed, you are not able to change the value of the resistance. The fixed resistor has more types. The first type is metal film resistor. A metal film resistor is looking like this. It's blue in color and it's also in gray in color. It's the internal structure of the metal film resistor. It consists of 2 leads, outer coating, inside the ceramic glass. On the ceramic glass there's a metal film which is rounded on the ceramic glass. So metal film resistor is a fixed value resistor. This resistor is very sensitive resistor. We can use this resistor on sensitive circuits. The range of this resistor is from 5 ohm to 20 mega ohm. This resistor we are using on that circuits where we need to reduce the noise. Means when we can use this resistor, so it will not producing a noise on the circuits. And we are also using this resistor on multimeter, because this resistor is giving a correct value in the circuit board. The error of this resistor is very low, and we are also using this resistor, a metal film resistor, on a signal generating circuits. For example, a remote control circuits, a radio circuits, or other signal generator circuits, because this resistor is giving the correct value, correct signal. The second type of resistor is a carbon film resistor. The carbon film resistor is looking like this. We are mainly using on all types of circuits. This resistor is not that much correct like the metal film resistor. You can see here this is also a carbon film resistor. This is the internal structure of the carbon film resistor. It also consists of two metal lid, middle glass ceramic rod. There's a carbon film which is rounded to produce the resistance. The carbon film resistor are using for protection of the circuits. If there's a high currents, you need to slow down, then we are using this carbon film resistor. Means this resistor we are using for current limitation. This resistor we are also using on a high voltage power supply circuits. Because the flow of current is very high or the voltage is very high, you need to control by the help of the carbon film resistor. The third type of the fixed resistor is wire wound resistor. A wire wound resistor is looking like this. This resistor is large in size. The value of this resistance is written on the body of this resistor. This is very powerful resistor. We are using this resistor on high voltage circuits. Means this resistor is controlling on high wattage, high currents, high voltage. This is also wire wound resistor. It is the internal structure of the wire wound resistor. We are using this resistor in high power circuits. We are also using this resistor on the circuit breaker. We are also using this in industries applications. We are also using this resistor as a fuse. The wire wound resistor is also called fusible resistor. Because we are using this resistor in high power circuits, so there's also the chances to fuse this resistor. The next types of the resistor is VDR resistor. VDR stands for voltage dependent resistor. It's also called resistor. It's looking like this. This resistor is also a resistor. We are using this resistor on that part of the circuits where is the chances to ups and down the voltage. So then we are using this resistor. It's controlling the varying of the voltage, means the up and downs of the voltage. When the voltage become high, so the resistance of this resistor become low. It will make the short circuit to save our circuits from the high voltage. This resistor is allowed to pass the extra voltage through its body. We are using this resistor parallel in the circuit. This is the symbol of the VDR, voltage dependent resistor. The next type is the thermistor. Thermistor is also called TDR, temperature dependent resistor. It's looking like this. This thermistor we are using in that parts of the circuits where the temperature is very high. We need to save our circuit from the high temperature because that temperature will be damage our circuits. We need to save that circuit from the high temperature. When the temperature become very high, the resistance of this resistor will become very high. When the temperature become very high, and there will be the chances to damage our circuits. So this resistor will help us to increase the resistance to stop the flow of current. When the resistance become very high, so there will be the chances to stop the flow of current. This is the symbol of the thermistor. When you see this types of symbol on schematic, so you understand that this is the thermistor. The next type is the LDR resistor, light dependent resistor. This resistor is very common resistor. It's also called light sensor. When the lights appear or draw on the surface of this resistor, so the resistance become very low. When the light is not appear on the surface of this resistor, so the resistance become high. We are using this resistor, a tow night light controlling circuit. Maybe you saw on the road, at night time, the light automatically become glow. This is due to LDR resistor. The next types of the resistor is a surface mount device, or the SMD resistor. It's a slim resistor and very tiny in size. This is the modern type of resistor which we are using in mobile phone circuits, laptop circuits, or other digital electronic circuit board. This is very small in size, but the value is same like the other resistor. The function and the work is also like the other resistor, but this is only small in size. We will discussing all types of SMD in the coming video. These were the types of the resistor. How to test and how to check the value of these resistors. This resistor has different value. So now in this video I am going to show you to test the value of the resistor. We are using these two types of multimeter. This is digital multimeter, while this is also. First we are going to check the value of the resistor through this meter. So friend, here you can see this sign is for ohm. We are going to use this area from this to this. When we can select this, we are able to check the value of the resistor from 0 to 200 ohm. From this range, we are able to check from 0 to 2000 ohm. In this range, we are able to check from 0 ohm to 20 kilo ohm. In this range, we are able to check the resistance between 0 to 200 kilo ohm. Well, in this range, we are able to check from 1000 or 0 ohm to 20 mega ohm. So now first we need to put this selector switch in the middle. If the range came on this position, so it will show the value. If the resistor range is above from this value, so the meter will not show the value. So then we need to take the selector switch up. So first we need to put here. Now let's check it. So first we need to take this resistor. So now you can see here the value of this resistor. The value of this resistor is 5.6 kilo ohm. Because the selector switch is in K. So therefore you can see here 5.6 kilo ohm. So the value of this resistor is 5.6 kilo ohm. You are also able to check the value by the help of color code. So now we are going to check this value of this resistor. So friend, you can see here the value is not showing. So we need to take this selector switch upward. Because the value is very high, this range is not able to show. So now you can see here the value of this resistor is 100 ohm. Now we are going to show the value of the resistor by the help of this meter. This meter is very good and powerful, and this meter is always telling the correct value, 100% correct value, and it's very easy to find the value. Just you check the selector switch here and the meter is ready. Now no need to change the selector switch. Just you can check the meter automatically tell us the value. So now you can see here we need to check the value of this resistor. The value is 100 kilo ohm. You can see here 100 kilo ohm. So now we are going to check the value of this resistor. The value is 5.6 kilo ohm. So now this meter is very easy to use. This resistor value is 31 kilo ohm. So friend, this was our video that how to check the value of the resistor. We will discuss about volt, ampere and watt. We are going to understand what's voltage, ampere and wattage. Before understanding this voltage, ampere and watt, we will take the example of water, because it's easy way to understand. You can see here, when the water is flowing through a pipe and you can put or keep the finger on the tip of the pipe, so the water become on pressure. So here the pressure is called voltage. So in electronics language, the pressure of these charges is called voltage. You can see here the electron is flowing from the positive to negative side. So the pressure of this electron or the charges is called volt. So the pressure of current is called volt. So now we are also taking the water example for ampere. So you can see here, friends, the water is consist of small tiny particles, mean a small drops. The drops of the water at the end become a hung amount of water. So like this, the charges also consist of a small tiny particle. That particle is called electron. So the amount of electron is called ampere. So you can see here in this circuit, there's a lot amount of electrons passing through a circuit, so it's mean the ampere is very high. And also you can see here in this circuit, the amount of electron is very low, so it's mean the ampere is low. So the number of electron is called ampere. So now we are going to discuss about wattage. What is wattage? So friend, you see here, this water is flowing on pressure, while this water is also flowing on pressure. Means this both water has pressure, but the power is different. This water has high power, while this water has low power. This power is come because the amount of water is very high. Also the pressure is also high. While this water has high pressure but low amount of water, therefore the power is low, while this water has high power. So you can see here also the dam example, the water dam. So this water is coming on high pressure and high power. So also in electronics, the power is called wattage. When the voltage and current both become high, so the power will be high. When both become low, so the power also become low. When one of them become high, so the watt also become high. Actually the watt is a power, volt is the pressure, ampere is the amount of electron, the number of electrons, like the amount of water, and wattage is the pressure and wattage is the power. I hope you understood this. We are discussing about diode. What is diode? Why we are using diode? What is the function of diode? A diode is basic electronics components. It's looking like this. The diode has two terminals, the positive side and the negative side. You can see here this mark. This mark indicates the negative side, while the other side, which do not have mark, that is positive side. Mainly the diode has two functions. It converts the AC current into DC currents. And the second function is that it allows the DC current at one side but block the DC current at other side. So see here, we have two types of charges, positive charge and negative charge. When we pass the positive charge at positive side of the diode, so the diode allows this charge. When we try to pass the negative current through positive sides of the diodes, so the diode will stop this charge. The diode is not allowing this current because it allowed a DC current at one side and block at other side. At same, the positive current is not able to pass at other side, means from negative side, but the negative current is able to flow from negative side to positive. This side is called positive, P, and this side is called N, means negative. This P and N is joined at the center, so therefore this middle is called PN junction. The second function of the diode is look like this. When we apply the AC current at this side or other side. So it converts this AC current, alternating current, into DC current or direct current. Here is the example of the sine wave of the AC current. When we pass this sine or the AC current through the diode from the positive side, it allows only the positive side but it will stop the negative sign of the AC current. So like this, the diode convert the AC current into DC current. So this was the two main function of the diode, the working of the diode. How many types of diodes are there? There are more than 20 types of diode. The list is here. The PN junction diode, small signal diode, rectifier diode, and more. The first types of diode is PN junction diode. The PN junction diode is mostly commonly usable diode. It's looking like this. And we are using this diode in every circuits. Here you can see there's a one sign which indicates the negative side, while the other side is positive, means there is a two terminal. This diode, the symbol of this diode is looking like this. The one side is called anode, while the negative side is called cathode. So here you can see we are using this diode in the circuit like this. This diode converts the AC current into DC currents. And this diode is also blocking the DC current at one side, but it allows the DC current at other side. This diode has different sizes, and each size it has its own value, means its own number. Larger in number have large power value, means small diode and large diode is same in function, but the power controlling is different. The small diode control the small power, while the large diode control large power in the circuit board. The second type of this diode is a Zener diode. This Zener diode is looking like this. There are different types of Zener diodes. These different types of this Zener diode is due to the voltage. The symbol of the Zener diode is looking like this. The Zener diode is working same like the other, but if we can use this diode at a reverse bias, so it can show its actual working. For example, we are using this diode in parallel in a circuit. We are not using this diode in series in circuit like other diode. You can see here, this is battery and this is LED. When we connect the positive side to the positive side of the LED and the negative side with the negative. So here, the voltage of this battery is 9 volt. We are controlling this voltage through the resistor. The extra voltage we are trying to drop through resistor. But in some cases, when the voltage become high, so there is a chance to damage the LED. To save this LED from damaging, so then we are using the Zener diode. So you can see here, this LED glow on 3 volt. The extra 6 volt will drop on this resistor. For safety, we are using the Zener diode in this circuit in parallel wise. So this was the function of the Zener diode. This is the list of the different value of the Zener diode according to their voltage. The next type of the diode is photodiode. The photodiode is looking like this. You can see here. It's also the types of photodiodes. The symbol of the photodiode is like this. You can see here. Sometimes the question is coming, what is different between photodiodes and the LDR? The function is same, but the photodiode cannot allow to pass the current at both sides. It allows the current to flow at one side but block at other sides. But the LDR allow at both side currents. The next type is constant diode. And how photodiode work? When the light touch the surface of this diode, so this diode become unfunction. The next type of the diode is constant current diode. Constant current diode work at that time when you need to flow the constant current in a circuit. So then we are using this diode. You can see here. We have 9 volt battery. When we want to use to glow this one LED, so it will damage our LED. So then we are using a resistor to control the extra voltage. If we want to put 2 LED, so it's need other value of the resistor like this song. So for AC, we are using a simple constant diode, constant current flow diode. This diode is coming on current base. For example, we need to flow 0.02 ampere current in circuit. So then we are using the 0.02 ampere constant current diode, which allow only 0.02 ampere current in the circuit. So this is the symbol of the constant current diode. So it is the circuit diagram of the constant current diode. The next type is the crystal diode. The crystal diode is looking like this. This crystal diode was using at old or the crystal radio circuits. At early, when the radio was making, so on that radio they were using the crystal diode. You can see here at the bottom there's a crystal diode which they use. You see here at down there's a crystal diode. The crystal diode is used in the radio circuits to stop the high frequency or to convert the high frequency into low frequency, because it allows to listen the higher frequency. The next type of the diode is LED, means light emitting diode. The LED is also the types of diode because it allowed to flow the current at one side but it blocked the current to flow at other side. The laser diode. A laser is also a types of diode. Vacuum diode. The vacuum diode is old types of diode which nowadays is not usable. At early, the new invention diode was vacuum diode. The function of the vacuum diode and the p-n junction diode is same, but this diode is very large in size, which after the time the vacuum diode is converted into the p-n junction diode. The next types of the diode is 10A10 diode. This diode is very large in size, but this diode is controlling even 10 ampere, means the power of this diode is very high. We are using this diode in high powerful circuits. So I will tell you that how to check the diode through multimeter. There are different types of diode you can see here, but the checking method is very easy. The checking method is same for all diodes. So now we are going to check only one diode. So the method is same for all diodes. First, you need to take this selector switch in here. This is the symbol of the diode. You need to take the selector switch here. Then this is the diode. The diode is giving the value at one side, but it's not giving the value at the other side. If the value is given at both sides, so the diode is damaged. If the value is not giving at the both sides, so the diode is also damaged. So first friend, you can see here, it's not giving a value. Now you can see here, it's giving the value. Also here, it's giving the value at one side, but it is not giving the value at the other side. So this means this diode is okay. The same process for this diode. It's showing the value at one side. You can see here, this sign indicates negative side. So the black wire is negative. So it's showing the value at this side, but it is not showing the value at this side, because the positive current is not able, or the diode is not allowing this current to pass through this area. So this was the method that how to check the diode. Capacitor. What is capacitor and how it can work and how it look like? Friend, this is a capacitor. The capacitor are different in sizes, and the capacitor also has a different shapes, but the functionality is same. All the capacitor have the same function. This is also the types of capacitor, the shape of the capacitors. But now in this video I will tell you that how actually the capacitor works. What is the function of the capacitor? So friend, the capacitor is simply like a battery. The battery is storing the electric charge, while the capacitor is also storing the electric charge. But what is difference between battery and capacitor? The difference between capacitor and battery is that when you charge battery, so the battery never discharges suddenly or fastly. When you touch the battery with the circuit board, so the battery is leaving the charge slowly on the circuit. But when you charge the capacitor will discharge very fast and very quickly. mean the capacitor never stored the charge for a long time, while the battery stored the charge for a long time. The capacitor pushing the current in a high power, while the battery is not pushing that much. When you short the battery, when you connect these two terminals with each other, so the battery will discharge slowly. It will take few time. While you short the capacitor, for discharging it will take only 1 second. So friends, see here how the capacitor stores charges. There are two metal plates. The one plate store negative charge while the other store the positive charge. Mean when we connect this capacitor with the battery, one side with negative and other side with positive. In the middle there is a paper or rubber, means non-conductive elements which can stop the charges to pass with each other of these two plates. You can see here in this plates the positive and the negative charges are attracting each other, but due to this middle plates it never become merged with each other. This is the symbol of the capacitor. When you see like this symbol on the circuit board, it means it's a capacitor. The capacitor never pass the DC current. It will stop the DC current and store this DC current on its own body. Well, the AC current can pass through this capacitor. This is due to the electromagnetic waves. Means the capacitor never work on AC currents. It only works in DC current to store the charges. For AC currents we need to use for a filtration. It can store the DC current. The capacitor is used for AC current filtration, means it will removing the noise from the AC current or electromagnetic waves. It is used for signal filtering. It is used for noise removing. For example, we are using a loudspeaker to remove the extra noise. When we remove the noise from the speaker during the music, so the voice become very smooth. So it means it's also work on smoothing. We are also using the capacitor to match the radio frequency or to take a specific frequency. Types of capacitor. There are mainly two types of capacitor: polar capacitor and non-polar capacitor. The polar capacitor are those capacitor which has polarity, mean which has positive and negative side, while the non-polar capacitor are those capacitor which do not have polarity, mean positive and negative sides. Both are working at the same way, means both are storing the charges. The polar capacitor we are using in power supply charger, adapters or high power supply for filtration to pure the AC current into DC current, while the ceramic capacitor we are using in the signal filtration or purification. There are different sizes and different values of the capacitor. The values depend on the voltage and microfarad. The voltage means of the capacitor, it has ability to work on that much value voltage, while the microfarad means the capacity, that how much capacitor have a capacity to store the current. The size of the capacitor is depend on the voltage and the microfarad. Here is the list of the non-polar capacitor value, voltage and microfarad. In the coming video we are discussing in detail on each part and each value of the capacitor. There are also different types of the capacitor like paper capacitor, ceramic capacitor and so on. We will discuss that in coming video. I hope you understood. What is transistor? Why we are using the transistor in circuits? What is the function or working of the transistor? So friends, see here. There are different types and different shape of transistor. So now the question is this: why we are using the transistor in our circuit board? So I will give you a simple example in here. For example, you have battery and one LED. You need to glow this LED by the help of battery. So simply you need direct connections between battery and LED. So the LED become glow. When you need to control this LED through a switch, so then you are putting a switch between LED and batteries. Through this switch you are able to control the LED, while the transistor also works like a switch. transistor never pass the current? Well, you give current in the middle pin or the base of the transistor, then the transistor allow the current to pass through LED and the LED become glow. So now here the question, what is difference between switching and transistor? The main answer is this: we are not able to fastly on and off, to turn fastly on and off, while the transistor is very fast on switching. Means in 1 second when you are turning the switch on and off, you are able to on and off the switch 10 times in a second, while in the transistor we are able to turn on and off 100 times or 1,000 times in a second. There are mainly two types of the transistor: PNP transistor and NPN transistor. So what is difference PNP transistor and NPN transistor? The difference is very simple. Here the circuit of LED and the cell or the battery and a transistor. When you give here the negative current, or those transistors which need negative current to pass the current through LED to allow the current from positive of the cell to the LED. So this transistor is called PNP transistor. Here the P means positive. When you give the positive currents, so the outside it's also giving the positive currents. By the help of the negative current, it allows the positive current to pass through LED. Well, in NPN transistor, we need to allow the negative current to the LED. So here the transistor not allowing this currents. So now here on the base, we are giving the positive current. So here we need to pass negative currents. By the help of positive currents, we are able to allow the negative current. So therefore this transistor is called NPN transistor. So the transistor works like a switch. And the second function of the transistor is the transistor works like an amplifier. Meaning the transistor amplifies the low signal into high signal. For example, your voice is very low, so the speaker is trying to loud your voice. So here in the circuit of the speaker, there is a transistor we are using, which can help to amplify your voice. So the transistor mainly has two functions: switching and amplification. The second example of the amplification is that when your signal is very low, you need to increase that signal. So then we are using the transistor. I hope you understood. Types of transistor. I told you before, the function of the transistor is a switching and amplification. But now I will tell you the types of transistor. The transistor mainly has two types: BJT, which called bipolar junction transistor, and FET, called field effect transistor. The BJT look like this, while the FET transistor is look like this. The BJT transistor further has two types: PNP transistor and NPN transistor. Also the FET has two types: JFET, junction field effect transistor, and MOSFET transistor. The MOSFET has further two types: depletion mode and enhancement mode. These transistor further has two types: PNP transistor and NPN transistor. We will discuss in detail on each types of the transistor in the coming video. I hope you understood. What is IC? IC is the short form of the integrated circuits. So before understanding the IC, I will give you a small example which is easy made to understand about IC. So here you can see, this is, for example, if you have a circuit, so in this circuit you are using a different types of component. You are using in here a lot of resistors, diodes, capacitor, different types of the capacitor you are using in the circuits, and also the transistor. So this circuits required a different types of components, and also during the making of this circuits it's also required lot of time. When you need to make these types of circuits in a hung amount, so it's required a lot of time. So then you are thinking, instead of these all components, can we use a small components which work like this? So then there is the option which you can convert this large circuits in a small size of components, which is called IC. So the IC is that component which consists of complex circuits. Means IC is that component in which there's a tiny small other electronics components. The IC become by the help of the small electronics component like resistor, capacitor, diode. So the IC is the complex circuits. Therefore, it is called integrated circuit. I hope you understood about the IC. So there is 1,000 or billion types of the ICs. Every companies need to invent their own IC or a circuit in IC form. So the checking process is also complex. Each IC has its own datasheet on which we know the function of each ICs. That how to read electronic schematic and how to understand the electronic schematics. Friend, if you want to make electronics projects or electronic circuits, so you need to first to understand the electronic circuits diagram, which is called electronic schematic. By the help of electronic schematics, you are able to make electronic circuit. The electronic schematics or electronics diagram is the combination of the symbol of the electronics components. Means these all are the electronics component symbols. First you need to learn the symbol of each electronics component. So here you can see these all are the symbols of the resistor. When you see like this symbol on the circuit or schematic, so you think that it's a resistor. This symbol is for diode. There are many types of diode and LEDs or the diode types. So each diode has its own symbol. This symbol is also for diode. When you see this symbol on the circuit diagram, so you understand that this is a diode, and each symbol has its own name. Like for junction diode, the symbol is like this. For Zener diode, the symbol is like this. For tunnel diode, the symbol is like this, and so on. This symbol is for transformer. There are many types of transformer. Each transformer has its own symbol. The name of each transformer is written in the front of the symbol. These are the symbol of the transistor. There are mainly two types of the transistor: PNP transistor and NPN transistor. So now you can see here the PNP transistor, the arrow sign is outward, while in the PNP transistor, the arrow direction is inward. The bottom all symbol is PNP transistor, while the upward all symbol is NPN transistor. When you see like this symbol in the circuit board or the symbol or schematic diagram, so you understand that this is a transistor. This is the symbol of the inductor. When you see like this symbol in the schematic diagram, so you understand that this is the inductor. There are many types of inductor. Each inductor has its own symbol. These are the symbol of the logic gates or ICs. Each logic gate has its own symbol, while the symbol of the ICs is equal. These all are the symbol of the electronics components. The name of each component is written in the front of symbol. So now just in a schematic diagram, you need to combine these components. At the end, the circuit will appear. Like you see here in this circuit diagram, this symbol is for battery, this symbol is for resistor, also this and this. This symbol is used for capacitor, this symbol is also used for capacitor, while the bottom symbol is used for transistor, and this symbol is the LED symbol. I hope you understood that how to read the schematic diagram of the electronics project or circuit. If you have any questions, so please write down in the comment below.
The multimeter allows several measurements to be taken. We can measure voltages. We then call this device voltmeter, since the unit of voltage is the volt. It can measure current intensities when it is an ampermeter. It can measure resistances. It is always used with two connection wires. One of the two wires is always placed on the COM terminal because it is the common terminal. The question will arise for the other connection wire. If we want to measure voltages, then there is a wire on the COM terminal. It always will be. The other wire will be on the connection terminal noted VV as volts. We learned here that the voltage measured at the terminals of the bulb, between these 2 points, is around 4 volts. You notice that the voltmeter is mounted in parallel, between 2 points. To have a more precise measurement, I can go down to 200 volts. I specify 200 volts because the ranges have a unit. We don't say the 200 range, we say the 200 volts range, which measures up to 200 volts. We can even go to 20 volts, since we can measure with this range up to 20 volts. So we can read 4.27. Can we go to 2 volts to measure this voltage? Certainly not. We avoid doing it. There, we can do it because we are in the virtual world. So what happens if I go there? Well, the screen tells me there is an error. So I must not stay in this position. We can measure alternating voltages, such as the mains voltage for example. Or the voltage across a transformer like here. You can use the multimeter as an ammeter. So here is the black plug, still on the COM terminal, that's invariable. The other wire, I put it here on the milliamperes terminal. And I chose the range that only measures up to 2 milliamps. Is this really a good idea? So, for now, I haven't closed the switch yet. I did not say that the ammeter was mounted in series. It is important to know that the same current flows through the ammeter as the following dipole. So here if I close here the current would go from the positive terminal to the negative terminal. It would cross the ammeter before crossing the bulb in series. The precautionary principle tells me that is not a good idea. And I would perhaps put, and you will see that it is the case, my device in danger. I first chose the larger range. That is to say 10 amps. If I put myself on 10 amps, well, the other wire must go, naturally, on the terminal 10 amps. There I can safely close the switch. 10 amps is a lot. So a range that measures 10 amps isn't a big deal. In fact, I'm reading something around 0.18 amps, which is around 180 milliamps. So I can afford to go on 200 milliamps. By changing the terminal, this time, I put it on milliamperes and, by closing the switch, I realize, indeed, that I have 184.7 milliamperes. I cannot be more precise because I already said 2 milliamperes, here, is prohibited. You must not go there. If I go, it is very serious. The ammeter, it is marked here, could be damaged. So, since it's virtual, I'm going. But it must not be done. we can measure resistances. By putting on 2 megaohms or 200 kiloohms, 20 kiloohms, the screen showed 0 because I was on very large ranges. I can go on 2 kiloohms, i.e. up to 2000 ohms, 2 kilo equals 2000. And I read that it is about 0.039 kilohm. What is on the screen is what is displayed at the same unit as the range. So since the range is kiloohms, what I have on the screen are kiloohms. So I can go over 200 at that point 200 ohm. What I have on the screen is in ohms. This resistance is 39 ohm. The resistance is not connected to anything else when it is measured. I could also evaluate it with the color code. That's it for this video. Thank you.
Hello friends. Today in this video I will tell you that how to test and how to check the value of these resistors. This resistor has different value. So now in this video I am going to show you to test the value of the resistor. We are using these two types of multimeter. This is digital multimeter, while this is also. First we are going to check the value of the resistor through this meter. So friend, here you can see this sign is for ohm. We are going to use this area from this to this. When we can select this, we are able to check the value of the resistor from 0 to 200 ohm. From this range, we are able to check from 0 to 2000 ohm. In this range, we are able to check from 0 ohm to 20 kilo ohm. In this range, we are able to check the resistance between 0 to 200 kilo ohm. Well, in this range, we are able to check from 1000 or 0 ohm to 20 mega ohm. So now first we need to put this selector switch in the middle. If the range came on this position, so it will show the value. If the resistor range is above from this value, so the meter will not show the value. So then we need to take the selector switch up. So first we need to put here. Now let's check it. So first we need to take this resistor. So now you can see here the value of this resistor. The value of this resistor is 5.6 kilo ohm. Because the selector switch is NK. So therefore you can see here 5.6 kilo ohm. So the value of this resistor is 5.6 kilo ohm. You are also able to check the value by the help of color code. So now we are going to check this value of this resistor. So friend, you can see here the value is not showing. So we need to take this selector switch upward. Because the value is very high, this range is not able to show. So now you can see here the value of this resistor is 100 ohm. Now we are going to show the value of the resistor by the help of this meter. This meter is very good and powerful, and this meter is always telling the correct value, 100% correct value, and it's very easy to find the value. Just you take the selector switch here and the meter is ready. Now no need to change the selector switch. Just you can check, the meter automatically tell us the value. So now you can see here we need to check the value of this resistor. The value is 100 kilo ohm. You can see here 100 kilo ohm. So now we are going to check the value of this resistor. The value is 5.6 kilo ohm. So now this meter is very easy to use. This resistor value is 31 kilo ohm. So friend, this was our video that how to check the value of the resistor. I given the link of this meter. You are also able to buy this meter. You can go in the description of this video to check this meter.